Yo, have you ever felt like reality is just kind of glitching? Like what if the fundamental rules we absolutely swear by? You know, the seconds ticking by your watch, or the actual physical distance of the street outside your window? What if all of that is actually just a completely fabricated illusion? Today, we are breaking down literally one of the most mind-bending paradigm-shifting topics in the entire universe. We're talking about special relativity. We're going to completely shatter your everyday intuition about how space and time actually work, taking some seriously complex physics and breaking it down into everyday reality. So stop in because things are about to get seriously weird. So let me ask you a direct question. Is time travel actually possible? I mean, we've all seen the sci-fi movies, right? The time machines hitting 88 miles per hour, the quantum realm portals, the whole shebang. And usually we just brush all that off as pure Hollywood fiction. But what if I told you that from a strict, mathematically proven, hardcore scientific standpoint, the answer to that question isn't a no? Yeah, you heard me right. Time travel is real, and the hardest mathematics in human history literally proves it. I know, it sounds completely insane, but this isn't science fiction. This is hard science. Derived from the absolute brightest minds to ever walk the earth. By the end of this explainer, you're going to understand exactly how you can travel into the future. And why the physical laws of our universe don't just allow time travel, they actually demand that it exists. Alright, let's dive right into part 1, the ultimate speed limit. Okay, so for centuries, Sir Isaac Newton told us that time was basically this universal absolute master clock in the sky. Tick, tock. Ticking the exact same way for everyone, everywhere, and the entire cosmos. If 1 second passes for you right now, a second passes for someone sitting on a planet clear across the galaxy. Makes sense, right? But then Albert Einstein comes along and completely shatters that entire worldview. Einstein realized that time is not some universal background at all. It's actually a deeply personal, entirely relative experience that depends 100% on your motion. Literally, your time is not my time. And the whole reason time is relative comes down to one absolute, unbreakable rule of the cosmos, the speed of light. In Einstein's universe, the speed of light is the absolute, undisputed speed limit of reality itself. And here's where it gets truly mind-blowing. No matter how fast you are moving, seriously, even if you were strapped into a rocket ship, rushing toward a beam of light at 99% of light speed, that light always travels away from you at the exact same velocity. It never speeds up, it never slows down. Which if you think about it, completely defies our everyday monkey brain logic. 299,792,458 meters per second. I want you to burn that exact number into your brain. Because this number, it absolutely refuses to budge. Whether you're sitting perfectly still on your couch watching this or flying in a hypersonic jet, light is moving at this exact speed relative to you. And because this number absolutely cannot change under any circumstances, well, something else in the universe has to give. If speed is perfectly constant, then time and space, they have to become the variables. Which brings us to section 2. Why time slows down. So here is the absolute crucial takeaway. Time is not a constant. Because that speed of light limit is completely inflexible, the universe literally has to bend time in order to protect it. Time itself flexes. Now I know that sounds practically impossible, right? Like how can time literally bend? Well, let's look at how this mathematically works out in the real world. I want you to imagine a clock. But not a standard clock with gears or springs or whatever. This clock measures time using a single particle of light, just bouncing vertically between two parallel mirrors, okay? Step 1. The light bounces from the bottom mirror. Step 2. It hits the top mirror. Step 3. That single bounce records exactly 1 tick of our clock. It is the most perfect, elegantly simple mechanism imaginable. When the clock is just sitting stationary on a table, right next to you, straight up, straight down, 1 tick, easy. But watch what happens in your mind's eye when we take this exact same light clock and put it on a super fast moving train. As that clock moves forward down the track, the light particle doesn't just go straight up and down anymore. Does it? I think it's a good idea to have a perspective, standing perfectly still on the platform and watching the train absolutely fly by. That light particle has to travel on a diagonal path to hit that moving top mirror. Now basic geometry tells us that a diagonal line is physically longer than a straight vertical line. Think about it like running straight across a street versus running diagonally across a huge intersection. It's just a way longer path. But remember our unbreakable rule. The light particle has a strict speed limit. It cannot just step on the gas to cross the longer diagonal gap in the same amount of time. So the actual duration of the tick has to expand. The second gets physically longer. The only mathematical possibility here is that it takes more time to travel that diagonal line. Therefore, the clock on the train is literally taking slower. Motion literally slows down time. Alright, let's keep going. Section 3, Space actually shrinks. Okay, if you thought time slowing down was wild, you better brace yourself for this one. Let's do a super quick logic puzzle together. We all learned back in basic school physics that speed equals distance divided by time, right? Simple fraction. Well, if the speed of light is perfectly constant, and we just logically prove that time slows down, meaning the bottom part of our fraction changes, what absolutely has to happen to distance to keep that final speed exactly the same? The completely mind-bending answer is something called length contraction. This is a proven, measurable phenomenon where an object in motion physically shrinks along the direction of its travel. Space itself actually compresses. Seriously, if you park a massive spaceship on Earth, it is one specific length. But if that exact same spaceship flies past you at incredible speeds, it physically compresses. A 100-foot ship flying fast enough physically shrinks to the size of a sports car from your perspective standing on Earth. And let me be clear, this is not an optical illusion. Your eyes aren't playing tricks on you, it's not some weird camera trick. The actual physical space it occupies has contracted. Reality itself is squishing. And listen, this isn't just some fun hypothetical math theory on a chalkboard. We see this in the real world literally every single day. Take these tiny subatomic particles called muons. They're created way up high in Earth's atmosphere. Now these little guys decay so incredibly fast that they shouldn't even survive the trip to reach the ground. By all normal logic, they should just vanish mid-air. But guess what? They hit the ground constantly. Why? Because they are moving so incredibly fast, the physical distance from the upper atmosphere to the surface literally shrinks from their perspective. Without length contraction, these particles hitting the Earth would physically break the laws of physics. It proves the math is 100% real. For a fast-moving traveler, the actual physical distance to distant stars like Proxima Centauri literally shrinks, meaning it takes far less time to cross. Moving on to section 4, the famous twin paradox. Okay, so we've shrunk space and we've stretched time. Let's put actual human beings into the mix and feel the visceral, crazy reality of this. Imagine two completely identical twins. Our Earth twin decides to just stay home, get a job, and live a normal stationary life. But our space twin decides to hop into an ultra-advanced rocket ship and take a high-speed joyride through the cosmos, traveling near the speed of light. Now because the space twin is moving so incredibly fast, their biological aging, their heartbeat, the firing of the neurons in their brain, literally everything ticks incredibly slow compared to the Earth twin. Imagine the space twin looking out the window just zooming past entire galaxies. To them, it feels like a quick 5-year trip. But back on Earth? The Earth twin is helplessly watching entire decades vanish. 50 long years go by. The ultimate, entirely mind-blowing conclusion of this paradox is that when they meet up again, the twins are literally no longer the same age. When the space twin finally lands back on Earth and pops open that spaceship hatch, they are physically 45 years younger than their own identical sibling. The space twin has effectively literally time-traveled into the Earth's twin's future. There's no flux capacitor involved, no quantum realm magic, just raw, pure speed, fundamentally altering the fabric of reality. Finally, section 5. Energy equals mass. You're probably sitting there thinking, okay, if going super fast lets us time travel, why don't we just build faster rockets? Why can't we just push the throttle down, hit the speed of light and go absolutely anywhere we want? Well, let's trace the logic. We know motion slows time. We know motion shrinks space. So what happens when you try to push a physical object faster and faster toward that ultimate universal speed limit? It takes massive, massive amounts of energy. But the universe, it acts like a giant cosmic speed bump. As you get extremely close to the speed of light, all that energy you're pumping and stops making you go faster. Instead, it converts directly into physical mass. Which leads us directly to E equals mc squared. Literally the most famous equation in human history. And look, this isn't just some boring dusty formula you're supposed to memorize for a high school physics test. No. This is the ultimate cosmic plot twist. It's the monumental realization by Einstein that brilliantly ties every single thing we just talked about together into one perfect package. Let's just break down the sheer insanity of what this actually means. E is energy, m is mass, and c is the speed of light. This incredibly simple equation fundamentally proves that energy and mass are the exact same thing. They are literally just two sides of the exact same coin. Think about that for a second. A piping hot cup of coffee physically weighs more than a cold cup of coffee, simply because it has more thermal energy trapped inside it. That is an explosive revelation. It means the physical matter that makes up your body, the device you're using right now, it is all just densely packed, frozen energy. Now, apply that mind bender to our spaceship. As you pump astronomical amounts of energy into your rocket engines trying to hit light speed, that energy literally turns into mass. The faster you go, the heavier you get. It's like trying to push a car that gets exponentially heavier the harder you push it. To actually reach the speed of light, your mass would become infinite. Which means it would require infinite energy to move you. The universe physically prevents you from breaking its speed limit, no way around it. So the absolutely crucial point we arrive at today is this. Your reality is entirely relative. Everything you experience in your daily life that you think is absolute. The steady ticking of your watch, your physical size, the passage of entire decades, your very mass is actually just an illusion. It depends completely on your perspective, and specifically, exactly how fast you are moving through the universe. Which leaves us with a pretty massive, completely perspective-shifting question to close on. If time and space, the literal fundamental building blocks of our very existence, are really just flexible illusions created by motion, what else about our reality is just a matter of perspective? Look around you right now. The universe isn't exactly what it seems, is it? Keep questioning, keep pushing the boundaries of what you think you know, and I'll see you in the next explainer.